morning, everyone. My name is Yan, and I'm currently an engineer for a company called Space Ape Games in London, where I build mobile games for a living. So I'm a long-time user of AWS. I've been using it for almost a decade now. And in the last 2 years, I've worked really closely with AWS Lambda in production, including working on some non-trivial serverless architectures, as you can see behind me. And I've also been very active in writing about and sharing my experiences and my lessons, and some of that work has also gone into the serverless well-architected paper published by AWS. So I'm here to talk to you about observability, which has definitely entered into the mainstream thinking in 2017, thanks in no small part to excellent writings by people like Charity Majors and Cindy Sriharan. And as Cindy mentioned in her post, that the first mention of observability probably came a few years earlier in a post by Twitter, where they were discussing the challenges that they had with debugging and troubleshooting this complex distributed system that they've built, which begs the question of what exactly is observability and how is it any different from just boring old monitoring. And the best way that I can think of to explain the difference is that monitoring is like having this guard tower where you're looking out for those known system failure modes like spikes in network I/O or CPU or memory usage, and the kind that lends itself really well to be shown on dashboards everywhere. Whereas observability is probably closer to what those government agencies are doing in terms of collecting high cardinal and multidimensional data about you so that they can understand this complex system of human interactions by just observing it from afar. And as Charity Major talked about in one of her interviews with Daniel Bryan for InfoQ, that when you're dealing with a complex distributed system, the health of individual services, or in this case, functions, are less important because they no longer tell the full story. It's hard to see the causal link between the health of one service or function to the level of experience that our users get when they interact with our system. So instead, we should focus on our ability to understand and debugging those complex interactions inside a system and focusing on those user actions that has a tendency to cut across multiple parts of our system. And that means we need to collect data from different dimensions around monitoring and everything else. And the telemetry we collect from monitoring is just one of the dimensions. And unlike monitoring, observability is also useful outside of incidents and outages. Then quite frankly, when you're dealing with a complex system like many people are building these days, you're going to need to have a good observability just to be able to understand and operate your system. And as companies are building these increasingly complex architectures, they also create tools in both the open source space as well as in the commercial space to help people gain better observability into their system. And of course, all of the tools and practices that have been developed recently, they have evolved with the previous generation of how we ship and operate software in EC2 instances as well as inside Docker containers. And when Amazon Lambda came along, we introduced this whole new paradigm of serverless computing, which has also introduced a number of interesting challenges to the current practices and tools that we have for observability. For starters, we have now lost the ability to access the underlying infrastructure that runs our code, so there's nowhere for us to install those monitoring agents and daemons that for so long has been quietly going about doing their job outside of the critical path where we are concerned with minimizing user-facing latency. So all of these agents and daemons, they would typically collect and batch logs or telemetry data in the background and send them asynchronously. And one of the things that we lost with AWS Lambda is the ability to do background processing outside of the few things that a platform does for you. And another major shift that has changed with Lambda is that concurrency, when our services are running inside EC2 instances or inside containers, are mostly managed by our own code. But with Lambda, the management of concurrency has been lifted up into the platform, which on its own is a great thing, because it means that our code are now much, much simpler. But at the same time, we also lost some economy of scale because the logs and telemetry data that used to be batched and sent at the instance level, they now at best have to be batched up at the concurrent execution level for your Lambda function. Which means in terms of the concurrency that our systems project onto those downstream monitoring systems, that concurrency is now much greater. And of course, you might say, well, there's a simple solution for that. You just use a bigger batch size, right? Unfortunately, it's not going to quite work. You see, when a new container has been spawned to run your code in response to some increased level of throughput to your system, and you're batching those telemetry data in between invocations, what happens if that elevated level of throughput goes down? Now, some of those containers are no longer necessary, and they will become idle and eventually garbage collected by the system, along with any data that you have batched but not yet sent. So if you're batching and sending them, then there's a very good chance for you to lose data as a result. OK, fine. Then we'll just send them eagerly at the end of every invocation. Perfect solution, right? Except, remember, there's no more background processing. So now you've got to send those telemetry data as part of your function's invocation time. And if you're talking about API, say with API Gateway, then API Gateway doesn't respond to the caller until your function has actually finished, which means all the while you're sending metrics and whatnot, the users for your system is waiting for your system to respond. And we know that elevated amount of user latency is going to impact revenue as well. So you're kind of caught in this catch-22 situation where on the one hand, you can lose data if you batch and send them, and on the other hand, you can add to your user-facing latency if you're sending them eagerly as part of your function's invocation. We're going to talk about some workarounds available to you, but even those workarounds themselves come with their own trade-offs. Another trend that I've noticed with serverless is that event-driven architectures has become much more commonplace, maybe in part thanks to the fact that it's really easy to implement them using technologies like AWS Lambda and Kinesis. And in general, we're seeing a lot of functions being loosely connected together through asynchronous event sources such as SNS and Kinesis, and even S3 and DynamoDB streams and so on. And of course, trying to trace those asynchronous invocations is much harder compared to trying to trace synchronous invocations such as API call. And that's just some of the challenges that a serverless paradigm has introduced to the practices of observability as of today. Let's look at some of the tools that we have at our disposal right now in terms of the 4 pillars that the Twitter engineers has identified in monitoring, alerting, distributed tracing, and the log aggregation. And since we're going to hear about IOPipe later from Cassandra, who's probably in the audience somewhere, let's talk about just the tools that comes with AWS as part of the package. So whenever your function writes to standard out, it gets captured by the Lambda service and shipped to CloudWatch logs asynchronously. And this is one of the few places you get background processing from the platform. And in addition, you also get information such as the UTC timestamp, as well as a unique request ID for the log. And the way logs are organized into CloudWatch log is such that you have a log group for every Lambda function. And for inside that log group, you have one stream for every container that's running your code. So you can loosely think of it as the level of concurrency that you have for the function. The problem with CloudWatch logs is that it doesn't make searching easy. And what most people do is they will actually ship their logs from CloudWatch logs to some other log aggregation service they want to use. And to do that, you can go to the CloudWatch logs console, click a cloud log group, say actions, and then just say, OK, I want to stream it to Amazon's hosted Elasticsearch service or to a Lambda function from where I can send my logs to whatever log aggregation service I want to use, which could be a self-hosted Outstack, or could be Splunk or Logly or whatever service you want to use. The thing to keep in mind is that every time you create a new Lambda function, you also create a corresponding log group as well. And you really don't want to have a manual process there for someone to have remembered to, oh, I have to go to CloudWatch logs and subscribe that log group to my log shipping function. And instead, what you could do here is to enable CloudTrail, so that allows you to create an event pattern in CloudWatch event, so that can invoke a Lambda function every time the system creates a new log group on your behalf. And you will call a Lambda function whose job is then to subscribe that log group to your log shipping function we just talked about. And it's a manual setup, but you don't have to do it by hand. You can actually include it as part of your serverless.yaml if you're using the serverless framework already. Another thing to remember is that by default, log groups are set to never expire. And since you are paying for data storage with CloudWatch logs, so it does have a long-term cost implication. So what you could do is to apply the exact same technique, but have another Lambda function whose job is then to update the retention policy to something more reasonable, like 7 days or 30 days. And by default, you also get a bunch of basic telemetry about your Lambda functions in CloudWatch, including invocation count, duration, error count, throttle count, and so on. And oftentimes, you also want to track those custom application level metrics as well. But remember, no more background processing. So now you've got to do it as part of your function invocation, which means your APIs are slower. And when you have microservices, those extra 10, 20 milliseconds you're just adding to send custom metrics can compound, especially when you have user actions that requires a couple of API calls to complete. So it doesn't actually take very much for you to end up adding 100 milliseconds to the user-facing latency, which, as Amazon found out, can easily reduce your sales records by 1%. So those extra milliseconds you're spending to send custom metrics can actually hurt your bottom line. So that's no good. And one of the things that you could do in this case is to piggyback off one of the background processing you do get with the platform by writing those custom metrics as specially formatted log messages so that your log shipping function can then later on pick them out, and instead of sending them to the log aggregation service, you will send them as metrics to your monitoring system instead, which could be CloudWatch itself. The trade-off here is that you're adding adding delay to seeing your metrics, and also you're adding costs with CloudWatch logs and function invocations. But you also have to manage the concurrency level for the log shipping functions so that it doesn't end up eating up all of your quota for the regional concurrent execution limit, which by default is only 1,000. And in return, you don't add any latency to sending custom metrics as part of your function call, which sounds pretty good, but it's still not the right approach for every single scenario. So I would say that for APIs, where you are very conscious about the latency you're adding to your users, so you should consider using this approach to send metrics asynchronously. But for everything else, where you're doing background processing and you're less sensitive to latency, at least those latency are not user-facing, then maybe you should send the metrics as part of your function's invocation. And once you've got all your metrics in CloudWatch or whatever other service you want to use, you do want to set up dashboards and alarms, both you can do with CloudWatch. And as for systems tracing, Amazon also has got the X-ray service, which allows you to see what's going on inside your function, especially if you've taken the time to instrument your code so that you get a very nice breakdown on where those milliseconds are going. In fact, if you call another Lambda function via Lambda's API, then you also get a breakdown for what happens inside the other function as well. But it doesn't work when you call another Lambda function via API gateway, because X-ray doesn't currently support API gateway, even though I'm pretty sure they're being worked on actively. And in my experience, X-ray is typically used to find out what's going on inside one function. So whilst it's very good for homing in onto those performance issues with a particular problematic function, it doesn't really do very much for me in terms of understanding or building up intuition about how my system is operating as a whole. And as the charity major already talked about, when you're dealing with a complex system, it's less about what happens inside one function, but rather the health of the entire user action, the code chain that cuts across your entire system. And it's here that I like to follow the request or follow the data as it enters into the edge of my system as a user request into an edge API, and then just travels through my entire system via both synchronous event sources like API gateway, as well as asynchronous event sources like SNS and Kinesis. X-ray also has got a service map view for the traces that you have collected, but just as the traces themselves don't span over asynchronous event sources, neither does this service map view. So whilst it's good for giving me a high-level view of the immediate dependencies of my functions, it's not so good for me to understand what's happening on the entire code chain as a user request comes into the system and to traverse through the whole of my system. And also, understandably, X-ray being an AWS service, it doesn't really help you with tracing requests to services that are outside of AWS. And if you're using something like Auth0 or Google Cloud Function or Azure Function as part of your architecture, then you lose that traceability. And finally, even though I know I've got an option to just go back to the dashboard and keep pressing the refresh button to see the new traces as they come in, For me, it still feels very much like a static view of a system that is alive, that's constantly doing things. Millions of things are happening at the same time, but I'm just there clicking a button to see a new trace every 2 seconds. We talk more about this static view versus live view of the system later, but for now, I just want to conclude by saying that I think the tools that we use need to move away from the current focus they have in terms of what's going on inside one function, but they should offer more help with us to help us better understand and troubleshoot what's going on in the system as a whole by focusing on those user actions that has got a tendency to just go across multiple Lambda functions inside our serverless architecture. And on one of my previous jobs, I migrated a social network to run on AWS Lambda. And one such simple user actions could be I create a new post, and that post should get distributed to my followers' feeds so that when they come to the app next time, they will see my post on their timeline, exactly like how Twitter timeline works. But even for a very simple user action like this, as you can see, multiple Lambda functions need to work together in tandem via both synchronous event sources such as API gateway, as well as asynchronous event sources like SNS and Kinesis for this feature to work. And as people, and as we are building more and more complex systems with serverless technologies, I think that's the area where we're going to need the most help from our observability tools. And with that, I'm going to go into the last act of this talk, where I share with you some of the ideas of, or rather, my wishes for what the future of serverless observability should be, and as well as some of the ideas that's been inspired by new features with the tools that are either already here or are coming onto the market pretty soon. Starting with dashboards. As an engineer that does a lot of operational work, I have used lots and lots of different dashboards, and by and large, I dislike most of them. For the simple fact that for every useful signal I get, there's just a huge amount of noise that I have to filter out myself. And I often get this mental dissonance as well, that most of my tools focus on what's going on inside one function or one component, and yet on my dashboard, all the information I need to understand the health of that one thing is splattered all over the place. Some are there, some are hidden inside this bunch of lines here somewhere, which is probably why that of all the dashboards I've used, the one that I enjoy the most is the one from Hystrix, where all the high-level and relevant information about the health of one component is all nicely in one place and visually encoded such that the most important information, like the volume of traffic and the health of the service, is also the most prominent and visually striking part of the dashboard as well. Of course, the data you get with Hystrix is not quite right for the use with Lambda functions. There's a whole bunch of things we don't care about, like the number of hosts that you have, but also we're missing important information such as the number of cold starts, invocation count, and so on. So let's give it a quick makeover. And we still keep the important information like the volume of traffic, overall health, as well as the percentile latency numbers. But let's also include the number of cold starts, like in both the absolute terms, but also in terms of the percentage of the total number of invocations. And maybe you want to see the estimated cost for your Lambda function in the maybe per second or per minute rate. And I want to see the current concurrency that I have for the function, as well as the number of failed invocations, both in terms of throttled, timed out, or just errored. And that's all very well and good, having all the high-level information about my Lambda functions in the one nicely positioned dashboard, but it still doesn't do very much in terms of helping me understand how the different parts of my system are connected and the health of those user actions that tend to cut across the entire system. And the way that I like to visualize my system is like a brain, where you've got neurons and you've got synapses that connect those neurons so the data can pass through the entire brain. And when I want to see how the brain reacts to external stimuli, you put someone into an MRI machine and you watch as the different parts of the brain just light up in real time when you inject those external stimuli, like pinch their arm or tickle them, and see what happens. And if you apply the same design thinking to dashboards, you might end up with something similar to Netflix's Visceral tool, which they actually open sourced last year, that allows you to watch in real time as traffic flows through your entire system. Or maybe how traffic are being diverted when one of the regions is suffering an outage. A live dashboard rather than a static one can give you a bird's eye view into your system as it lives and breathes. And maybe occasionally you want to take a pause and just pick out one of the currently executing threads and see what's going on inside and really drill deep into it. And this is where you can figure out how the different parts of your system are connected. And to do that, you need to be able to trace over asynchronous invocations, as well as any resources that you're using that are outside of AWS boundary. And instead of forcing me to jump between different tools to see different views of the same system, the same trace, I should have all the relevant log messages for just this particular thread of execution right here at my fingertips where I need them the most. And I should be able to sort them by clicking on a column heading or click on a row and expand it to see what other information has been recorded as part of that log message. And when I click on a function, it should also just filter out all the logs to show me just the log messages for that particular invocation. And since the tool also knows that I'll click on a function, maybe it will show me this tiny tooltip that allows me to quickly pop over the Cloud9 IDE so that I can correlate between what I see in the logs with the code that I see for this particular function. And I also want to see the input and output for that particular invocation so that, again, I can correlate between the logs to the actual arguments that my function was invoked with and what it responded with. And if I click another function, I should see that function's input and output as well. And if one of the functions errored, I also want to see the error message and stack trace if one is available. In fact, the tool should also highlight those functions that has either timed out or errored so that they're very visually prominent and something that I can really quickly identify when I look at a trace. So that's all well and good. What else are we missing here? That's right, we are missing the performance traces. And we probably care about how long the entire workflow took, as well as the breakdown for the different parts, so that when I click on a Lambda function, for example, it will highlight the traces that's relevant to that particular function invocation, as well as any breakdown I get by instrumenting my code to get additional information about how much time is taken at every single step. So the idea here is that I should have one place where I can satisfy all of my tracing needs rather than have to hop between multiple tools to get different views of the same trace. And the other thing that strikes me when I look at a service map like this is that I'm actually looking at a graph, as in there are nodes and there are vertices that connect them. So what if the data underneath can be recorded as a graph and queried like a graph as you would do with a graph database such as Neo4j or Amazon's new graph database, Neptune? That's going to open up a whole world of possibility of us not only querying by the metrics or properties of a particular component, but also by their relationship with each other. You might ask, why is that even useful? I think it's going to be very useful because whenever you do any form of root cause analysis, as the name suggests, you're looking for that causality to help you understand to help you answer the question of what causes abnormal behavior that we were able to observe or being reported by the users. And oftentimes, when you start investigating these abnormal behaviors, you start by looking for other abnormalities in the entire system just blindly based only on temporal correlation. But that correlation doesn't necessarily mean causality. In fact, oftentimes it's hard to tell the cause from the symptom because the relationship of the correlation is not immediately obvious to you. And that's oftentimes when you have to fall back onto the experts of a system, the people that develop a system, because those relationships that only exist inside the mental models that they have about the system. Now imagine if those relationships can be explicitly captured and queried. And with a simple graph query, you can start from the point of interest where you've observed the abnormal behavior in the payment service. Instead of looking for blindly for temporal correlations inside the entire system, you only look for the things that it depends on either directly or indirectly. You might find very quickly that, oh, right, there's some temporal correlation with some elevated number of throttle exceptions on the user table, which is used by the user service, which is dependent upon by the payment service, and that's why we're seeing slowness in the payment service. Now that you've identified a culprit, you can also quickly use the graph query to expand the search to find other things that could have potentially been impacted, but not severely enough that it gets picked up by your monitoring and alerting systems. And you can also apply a quick query to see, okay, if anything, any of these services has got an slightly elevated rate of error or maybe slightly higher latency than normal, to find other things that you may want to investigate as well. So I think it would be really cool, or at least very powerful, to have this additional dimension of data that you can query whenever you're doing an investigation. In the last couple of years, we also heard a lot about big data and machine learning and deep learning, and we are really good as an industry to apply those technology to help us improve our products and services. So what if we turn around and apply the same know-how and help us improve the way that we operate our systems? So maybe we can use machine learning to help us also detect erroneous or suspicious behaviors or suggest us improvements that we can make to our system. In fact, Amazon's already doing this with services like GuardDuty and the Macy. So we've got a system behind the scenes that are constantly learning about how our functions operate, what resources they access, and they can then notify us when they notice the odd or suspicious behavior, like, oh, that other function just started writing to a table that is never done before. Is that right? And if you happen to be in the dashboard, maybe you pop a little thing to say, hey, do you want to do something about this? Or maybe you send you an email with actionable links that you can say, don't worry about it, it's a new feature, I know what it's doing, don't worry about it. Or, oh my God, what the hell's going on? Let's quickly auto-modify the IAM role so that we put a stop to this madness right now. Also, the system may be learning about the performance characteristics of a function. It may be able to tell you that, hey, since you did that release last week, that particular function is now running 40% longer than it used to. Maybe something that you want to look at. Or, hey, you've got a function that is running, that's averaging 102 milliseconds, so you're actually getting charged for 200 milliseconds. So maybe you want to run it on a slightly higher memory setting so that the function runs faster, but also you get charged for 100 milliseconds rather than 200, so you save some money as well. And whilst you're here, I can make that change for you right away if you just click on the link. So those are just some of my ideas for things you could potentially do in the serverless observability system. But of course, I don't have a crystal ball. I can't tell you exactly what's going to happen. As Simon Wadley, one of the, I guess, a noted advocate for serverless technology, will often say that businesses need to develop a sense of situational awareness, and they need to use tools that give them the context and movement of what's going on around them so that they can make the correct or the best business strategy decisions. And as engineers that work with complex distributed systems, we also, where we care about the user actions that tend to cut across multiple parts of our system, we also need tools that's going to give us the context as well as the movement of data in order to help us understand and make the best decision about how we operate our systems. And as Alan Kay would say, the best way to predict the future is to invent it. And I would like to thank a few people that are definitely inventing the future of serverless observability and for giving me early access to see what they are working on. So I'd like to thank the guys from Thundra, as well as Nissan and Rand from Absagon. I think they've got a booth outside. Check them out. And also the guys from IOPipe as well to show me some of the new features they've been working on. And if you want to learn more about observability or just SI in general, here's a bunch of people that may want to follow on Twitter. And lastly, a bit of a shameless self-promotion. I'm actually working on a video course with Manning that covers a bunch of different topics to help you get production ready with serverless. And whilst it's in early access, you can actually get 40% off with the code on the screen. And they've actually given me 3 copies to give away for free today. So come and talk to me afterwards if you're interested. Thank you very much.